We're trying to prove that if A divides B, then AC divides B times C. Again, all letters are arbitrary integers. You should start by saying let A, B, and C be arbitrary integers. And suppose A divides B. Now I'll just write implications. By definition of divides, that means there exists an integer k such that B equals k times A. To say A divides B means that B is an integer multiple of A. You're not doing division. You're not doing A divided by B. This says B is an integer multiple of A. That's what we're saying here. That's what it means to divide. We're trying to show AC divides BC. It's really just a matter of multiplying both sides by C. BC equals KAC. Maybe for extra emphasis, you want to use the associative property, but it's not a big deal if you didn't. That's the same as K times AC. So what do we have here? We have BC is an integer multiple of AC. Therefore, AC divides BC. Okay, that there is enough to say that. K is an integer. This does fit the definition of divides. Question?
Could you divide by C and say that it's the same thing?
We're kind of mostly trying to avoid doing any division, any literal division. Although I will say in looking at the proof of the division algorithm, the author actually does a little division in there. We'll look at that proof today. So that's kind of violating the spirit of what I'm trying to get across, but we'll live with it there. We're trying to write just things in terms of addition and multiplication mostly. Property 2, suppose we would again start by saying let A, B, and C be arbitrary integers. But now we're supposing two things. Suppose A divides B and B divides C. That implies there exist two integers, say K and M. Yes, I know L is the next letter in the alphabet, but L sometimes looks a bit too much like a 1. Integer Z such that B is K times A and C is M times B. What are we trying to show? We're trying to show A divides C. It's just a matter of combining these two equations. C equals MB, but B is KA. We're trying to show A divides C. We're almost there because of the associative property. This is MK times A, where M times K is an integer. Okay, if we were extra picky, we would also be emphasizing closure of the integers under multiplication. M times K is indeed an integer. So C is an integer multiple of A. That means A divides C. Do you really need to use the associative property? If I put this on the test, do you have to show these couple steps with the associative property? That's not too much of a big deal to me. If you just wrote one of these two things without parentheses even, I'd be okay with getting to the final conclusion here. For the third property, give me 5 arbitrary integers, A, B, C, S, and T. Suppose C divides A and C divides B. Show that C divides this arbitrary linear combination of A and B. That's a linear combination, just like in linear algebra. Although in linear algebra, you did linear combinations of vectors. Here we're doing a linear combination of two integers, A and B, thinking of them as given integers, say, and S and T as arbitrary other integers. We have a theorem called the GCD is a linear combination theorem, which we'll talk about today. That it's good to emphasize that terminology. So again, same kind of stuff at first, and then suppose C divides A and C divides B. So again, there exists K and M. in the integers such that, I mean, the row of the letters in property 3 is switched around a bit from property 2, so you got to be careful. C is dividing A, so A is, say, K times C, and C divides B, so B is M times C. Always ask yourself, what are we trying to show? We're trying to show C divides AS plus BT. Yeah, you got stuck there, like, what should I do? A good problem-solving strategy is to go ahead and start with what you hope to show is a multiple of C in this case. This implies AS plus BT. What can I do with this? I can do substitution. And again, I'll use parentheses here. A can get replaced by KC, and B can get replaced by MC. And then ask yourself again, what's the goal? The goal is to show C divides this. Hey, I see a C in both terms here. Maybe for emphasis, I'll get rid of the parentheses and rearrange. Maybe I'll also put parentheses around the other terms like this, just for emphasis. It's not necessary if you don't put parentheses. And then factor out the C. You do need parentheses here. Okay, this is the distributive property. You do need to make sure you put parentheses around the KS plus MT. And yeah, by closure of the integers under both multiplication and addition, this is an element of Z. So AS plus BT is an integer multiple of C. Therefore, C divides AS plus BT.